Hi everyone, and thanks for joining. Today I'm going to walk you through this last unresolved box from Starting Point Tier 2. Don't forget to contemplate the series of machines, and that's this one, base. Very easy Linux machine. I'm already connected to Hacked VPN network. I'll refresh the interface to see the change in my connection reflected faster. There it is. Let's see details of my VPN configuration. There they are. With that, let's proceed to spawn the target instance. This base very easy Linux machine has tags vulnerability assessment, custom applications, source code analysis, authentication, Apache, PHP, Reconnaissance, website structure discovery, SUDO exploitation, authentication bypass, clear text credentials, arbitrary file upload, information disclosure, and PHP typo juggling. So we have an idea what to expect. We'll see and learn from this box. We have target machine IP address back, and let's proceed to ping it, though it's not necessary for the target instance to reply to ICMP echo requests. Okay, the machine is responsive, and we see TTL63 as expected for Linux instance on this platform in this case. And let's proceed according to the walkthrough, mostly focusing on hands-on tasks. Let's run nmap with switches SCSV, and I'll add the -vv for very verbose, and with that we expect to get 2 ports reported back as open, 22 and 80. And we'll start off with enumerating port 80 using our web browser. So let's do this part hands-on. I'll omit sudo prefix. It's not necessary to run nmap with these switches. Almost immediately we see discovered operand ports 22 and 80, and for the sake of time I'll immediately switch to web browser and this web server hosted on port 80. Later I'll refer back to nmap output and copy paste it in my notes file. We expect to see such page in the browser, and we'll refer to the login section top right and to see such login form. And we see this login PHP file is hosted from login directory. Let's omit this login PHP part to see if this login directory is listable. And it is. We see 3 files listed over there: config PHP, login PHP, and the login PHP SWP swap temporary file. And let's proceed to download this temporary swap file and read it. So this login PHP swap file as a temporary file contains a lot of non-human readable content. Thus we will use the strings utility to read this swap file, because strings will only display the human readable text. I'll download this swap file. Let's run strings on it. Let's save it in our notes file. And after looking at this file for some time, we would notice that it's kind of printed out on our screen the other way around. So we'll use tech utility, which reads files similar to cat, but instead does so in the backwards manner. So now it looks better from beginning of the header to end of the header, for example. Also CSS, and starting from PHP section, it looks better and nested as expected. Let's save this in our notes file. And after analyzing the file, here is the part that is interesting, highlighting this two row mentioning string compare function. And more on string compare you can see on this PHP page. So this file checks the username password combination that the user submits against the variables that are stored in the config file, which is potentially communicating with the database to see if they match. Now here is the issue with this string compare username and post username equals 0, then if string compare password, post password equals 0. The developer is using the string compare function to check the username and password combination. This function is stored for string comparison and returns 0 when the two inputted values are identical. However, this function is insecure and the authentication process can potentially be bypassed without having a valid username and password. This is due to the fact that if string compare is given an empty array to compare against the stored password, it will return null. And in PHP, the equals operator only checks the value of a variable for equality, and the value of null is equal to 0. The correct way to write this would be with the triple equals operator, which checks both value and type. These are prominently known as type juggling bugs, and a detailed video on this can be found here. In PHP, variables can be easily converted into arrays if we add squared bracket in front of them. For example, exchanging $username to $username square brackets. Adding square brackets changes the variable $username to an array, which means that string compare will compare the array instead of a string. And in order to exploit this vulnerability, we'll intercept the login request and manipulate it using web proxy, such as Burp Suite. I'll configure Burp using Foxy Proxy plugin and intercept the login PHP request. and adjust this post request from this line username equals admin and password equals pass to username open and closed square bracket equals admin and password open and closed square bracket equals pass. And with that, we should be able to log in. Once logged in, we will see file upload functionality and proceed to work with it. Now let's pause with the walkthrough and do this part hands-on until we get to this section. I'll first try to log in with the set on credentials admin pass. I expect it to fail, then in burp I'll find this request and modify it. So string compare functions compares arrays instead of strings, as so. Here is the login form. So let's try with this set of credentials, admin and pass as password. We expect it to fail. As expected, we have wrong username and password. Okay, let's prepare burp and foxy proxy to intercept this web request. There it is. I'll send it to repeater. And let's see here, if we send this request as is, the response will contain this alert, wrong username as password, as we saw in the browser. And let's adjust this payload to the one from the walkthrough with squared brackets. And send it now. Now we have a different response mentioning welcome to base, and let's notice in upper left corner follow direction. Let's click on it. And finally we have response with status code 200 showing base file upload and admin file upload. This looks better now. So back in proxy, we see the web page is still hanging. So there is this web request that's not yet forwarded. So as seen in the repeater, I'll adjust this line to refers to arrays, not strings, and forward it that way. Let's click first once forward. And let's click on forward once again. Great. We now have access to uploads page. For now, let's disable Foxy Proxy. If we need it again, we'll re-enable it. And as we notice, this website works with PHP pages, so let's try to upload one test PHP file containing PHP info function, which outputs the configurational information of the PHP installation. Let's test it out. we expect to see this note: your file has been uploaded successfully. When we upload this test PHP file, let's try that out. Then we will figure out with GoBusterDir where uploaded files such as this one, test PHP, are stored. And we see the note: your file has been uploaded successfully. Great, so let's proceed with GoBusterDir command. And we'll adjust it with our specific target IP address and full path for this word list. Let's see if I have it already available somewhere on my attacker machine. And let's try to locate this big.txt word list. It should be related to dirb. Let's try with the locate big.txt. And I see it here. User share dirb word lists big.txt. It's a bit different than in the walkthrough. Let's give it some time, and we expect after some time to see this folder lower line uploaded. And we'll navigate to it to see if our file is there. We expect to see this recently uploaded test PHP file listed or there. And by clicking on it, we expect to see output of the PHP info command, thus confirming code execution. With that, we will create a PHP web shell which uses the system function and a CMD URL parameter to execute system commands. And we'll create a file web shell PHP with this content: PHP echo system request CMD. Back in the terminal, GoBusterDir found uploaded directory, so I'll stop it now for the sake of time and refer to the uploads directory. Great, this part is as expected. So let's proceed to create this web shell PHP with this content. And let's proceed to upload it too. And then with right mouse click, we'll copy its URL location, then paste it in address bar and add $CMD equals ID. So with established PHP command execution, if we add a system command in the CMD URL parameter, a PHP backend will execute its value, for example, $CMD equals ID. And we expect to get the output of the ID command, as seen on the screenshot, letting us know that Apache is running in the context of the user www-data. We will intercept this request in Burp Suite and send it to repeater. Let's pause with the walkthrough now and do this part hands-on. This file has also been uploaded successfully. Let's refer to the uploaded directory. And let's refresh our view. Great, there's web shell. And now let's copy link. And let's add here $CMD equals ID. Great, we see the output of ID command, confirming that the web server runs in the context of www-data user. I'll re-enable Foxy proxy. Then in burp, let's confirm intercept is on. And let's refresh this page. There it is, this web request. And let's send it to repeater and change the request method from this get to post. If the request stays as HTTP GET request, it is likely that one might encounter errors due to the presence of special characters in the URL, even after URL encoding them. Instead, we'll try with converting this get request to a post request and send the reverse shell command as a HTTP post parameter. In repeater, we'll also adjust the payload part to contain this bit. Then URL encode it. It's important to URL encode the payload, or else the server might not interpret the command correctly. Before we actually forward this request to the web server, I'll start netcat local listener on port 443, and of course adjust this payload to contain my attacker's IP address and port 443 where netcat will listen. And let's pause here with the walkthrough. Let's do this hands-on now, until lateral movement section. We see here content type, xwww form URL encoded. So we'll URL encode this bit. Let's URL encode key characters. Let's start local netcat listener. I should add my IP address and listening port. So let's do that now. And let's try to run this from repeater. Great, we have a connection established. For lateral movement, we'll navigate to the directory var www html logging that we saw mentioned in the swap file. Let's remind ourselves of that. There it is. We'll refer to it and see what we have there. And we would go through each of these files, but for the sake of time, let's start with config PHP and read its contents. And we have a username admin mentioned with this password. Let's save it in our notes file. This config PHP file reveals a set of credentials. System administrators often reuse passwords between web and system accounts so that they do not forget them. Let's enumerate further to see if this password is valid for any system user. To do that, we can first list the files in the home directory to quickly try to identify users on the system. So let's run ls/home. And there is John. A folder called John is found, which gives us a valid username. So let's try to switch our current user www data to John with this password. That does not work. So in the beginning, in the nmap output, we saw there's port for SSH by default 22 open, and with this password, let's try to SSH to target instance as a John user. Let's have this password in here. Great, and we successfully SSH to this instance as the John user with the newly found password in config PHP file. And let's get out the content of user.txt file. And this is the right path to get the user flag. And that command will work to get the content of user flag. Now let's try to escalate our current privileges to get the content of a root user who has the highest privileges in the system. Instead of running a system enumeration tool like CleanPiece, let's first perform some basic manual enumeration upon checking the sudo-l command output, which lists the sudo privileges that our user is assigned. We will see that user John can run the find command as a root. Let's check that out. There it is. And it's rarely a good idea to allow a system user to run a binary with elevated privileges, as the default binaries on Linux often contain parameters that can be used to run system commands. A good list of these binaries can be found in the GTFO-Beans website. GTFO-Beans is a curated list of Unix binaries that can be used to bypass local security restrictions in misconfigured systems. And for Windows systems, the equivalent of this is the lolbas. And let's now refer to GTFO-Beans website, search for find, and read through the sudo bit of instructions to get an idea how we can escalate our privileges. Here is the GTFO-Beans, and let's showcase quickly lolbas. So for our case, we need find with sudo function, and let's disable Foxy proxy from running. We don't need it anymore. Let's refresh the page. This is the section of our interest. If the binary is allowed to run as super user by sudo, it does not drop the elevated privileges and may be used to access the file system, escalate, or maintain privileged access. So we'll run this command. And as mentioned in the walkthrough, the -exec flag is used with find to run some command on each matching file that is found. We'll abuse this to just run a shell, and since the process is running as a root from sudo, that shell will also be running as root. Instead of sh, we will use bash as it offers better syntax, and it is actually an improvement over sh. Once we run this command, we should successfully obtain a root shell. Let's try this out. Great, we have a sharp sign back, so let's confirm with who am I and ID. And let's navigate to root directory to get the root flag. And let's get out the root flag. Task 1. Which two TCP ports are open on the remote host? We saw and interacted with 22 and 80. Task 2. What is the relative path on the web server for the login page? So that was /login/login.php. Task 3. How many files are present in the login directory? We saw 3. Let's confirm from the notes. That's this, config PHP, login PHP, and login PHP swap. Task 4, what is the file extension of a swap file? That's .swp. Task 5, which PHP function is being used in the backend code to compare the user submitted username and password to the valid username and password? And that's strcmp with open closed parentheses. Task 6, in which directory are the uploaded files stored? That's /lowerline uploaded. Task 7, which user exists on the remote host with a home directory? That's John. Task 8, what is the password for the user present on the system? Let's refer to our notes. So this is this one we found in config PHP file. Task 9, what is the full path to the command that the user John can run as user root on the remote host? Here we saw the full path. Task 10, what action can the find command use to execute commands? That's exec. And finally, let's submit user flag and root flag. Great. With this, we can say we completed the box, and in my case, the whole starting point set of very easy machines. If you enjoyed this video, don't forget to like and subscribe. Until next video. Bye for now.